So it's real simple to figure out how to find the union and the intersection. There are some other operations, but like I said, this is supposed to be just a summary of what a set is and talking about subsets and then elements. So I'm going to actually now let's do a little quiz here. We talked about first, in the very beginning, the set n. And the set n consists of, well, the numbers that were first introduced to us way back when, right? And dot, 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 goes on forever. Okay, the question is this a finite set or an infinite set? This set is infinite because it goes on forever. If I were to say, let's look at this set here. So this is kind of a special set. As you can see here, this is the set of odd numbers, right? This is the set of odd numbers. So I don't know, we'll say odd numbers here, and we'll call this one even numbers. So this is going to be the set of even numbers, 2, 4, 6, 8. Whoa, there's supposed to be a 6 there, Nelly. 2, 4, 6, 8, 10, and on forever. So this is the set of even numbers. If I were to take the set of, why did I put an N here? This is the set of odd numbers, yeah, even numbers, okay. The set of odd numbers and union that with the set of even numbers, we would get the set of natural numbers, right? We'd get the set of natural numbers because we would just join all the odds with all the evens and we'd end up with, well, this set right up here. But if I were to take the set of odd numbers and intersected it with the set of even numbers, right? What do these two sets here have in common? And that is not much at all, right? They don't have anything in common. So this would end up becoming the empty set. Now, real quick here, I just now realized something. If I'm given the set A, B, and C, and we'll call this set X, X, and we'll call this set Y, B, and C. Okay. Is set Y a subset of X? Y is a subset of X, and that is yes. B and C are contained in X. Now this set is known as a proper subset. This is called a proper subset. Alright. ABC is not a proper subset. In other words, the set is a subset of itself, but it's not a proper subset of itself. So if I were to say, if I were to give some set Z and I said this here, then basically what this says is this set Z here must be a proper subset of X. Okay, this must be a proper subset of X if we don't include this bar down here. But if I include the bar, then basically what that is saying is okay, Z could be X. We could say that Z is actually X. Okay, hope you're not getting confused there. So we looked at two kinds of sets. We looked at finite sets and infinite sets and subsets and things like that. Let me ask you this before we go. Is K an element of X? And the question, or the answer to that is no, and we'd put a line through it. K is not an element of X, but C is actually an element of X. We could say right there.